Now, just before we go on to method 2, I've written a little summary here. When you are solving sine, cos or tan, so just one of the 3 basic trig ratios of theta is equal to some number. So you've got this situation, you've got an equation because you've got an equal sign. A basic trig ratio of an angle, an unknown angle, and you've got it equal to a number 1. Register if this number is a positive or negative. Now that's pretty easy. It'll be a positive unless it's got a negative in front of it. What you do then is you identify the quadrants that theta must be in using, obviously, the ratio that's given here and this understanding that all trig ratios are positive in this ratio, this quadrant, only sine is here, only tan is here, and only cos is here. Once you've established which quadrants you're going to be in, then you need to find the actual size of theta. And to do that, you use this little summary. If you're in the first quadrant, then the angle will just be theta. If you're in the second quadrant, obviously you've got to work out what the acute angle is, but you're going to give your answer as 180 minus that acute angle. If you're in the third quadrant, you write the actual size as 180 plus theta, and if you're in the fourth quadrant, you write the actual size of theta or size of the angle as 360 minus theta. So that's just a little summary of method 1. Let's move on to method 2. What if the trig equation you have involves a reciprocal ratio? So which are the reciprocal ratios? They are cosec, sec, or cot. So it's saying simply, when equations involve cosec, sec, or cot, take the reciprocal of each side of the equation. Now, I could show you the long way why you do that. And so let's do that now. If you've got cot of x is negative 1/3, cot, so you'd start off, cot x is negative 1/3. Cot is 1 on tan of x. And you can put that line in if you like. 1 on tan, because cot is just straight replaced with 1 on tan. Now you take the reciprocal, turn each side upside down, and you get that tan of x is negative 3. Then to get x, you want the tan inverse of negative 3. Nothing is sounding or looking familiar in that negative 3 for a tan ratio. 1 or 1 on root 3, or root 3 on 1 would ring bells in terms of the 2 little exact triangles, but minus 3, nothing is familiar with that, so you would need to go to your calculator. What I didn't point out is that when you take your reciprocal, you will produce an equation that actually we solve via method 1. So here was that point. Tan of x is negative 3. So at negative 3, what would we be doing? We would be registering the sign. It's negative. Where is tan actually negative? Well, not there. Tan is negative here, not here, but tan is negative here. So we want to be in quadrants 2 and 4. That's really important. I would find my acute angle by going to the calculator. So let's have a look at that. Oops, let's see if I can move that so that you can actually see. Second function tan of -3, close the bracket, equals, it's saying it is -71, which is fantastic. It's said it's here it's actually giving me the value of the angle in the fourth quadrant. However, we wouldn't, and I'll call it -72. So x by my calculator is -72. We don't give the angle as a negative unless we were instructed to do so. So actually what it means is that my x, or my acute angle, would be 72. In the fourth quadrant, you could start there if you like. In the fourth quadrant, that's 360 minus 72, and 360 minus 72 would be 288. And so that is one angle for x. The other quadrant that we've established we have to be in is the second quadrant, where we name the angles as 180 minus 72, and 180 minus 72 is 108. Therefore, x is equal to 108 degrees and 288 degrees. And what you can always do is you can always find, and in this case you could find the tan of that angle, of tan of 108, and raise it to the power -1, which will give you the reciprocal, and see if you get -1/3. I'm going to stop the video there. Hopefully you can see, and you will be able to recognise in the future what method 2 is. It involves a reciprocal ratio, and see that what I had said previously about reverting back to needing to use method 1 actually became true and obvious in this case.